Hello Year 7, today's lesson you have a do now to begin with. Please complete this in your exercise books. Pause the video and complete your do now. Here are the answers for your do now. Today's lesson is on identifying chemical changes. Please write the title at the top of your page. So, first of all, what is a chemical change? A chemical change is a change that makes a new substance, and this means that the atoms change how they are bonded together. So, in the first picture on the left, you can see that A is bonded to B and C is bonded to D. During a chemical reaction, all of those bonds are broken, leaving the individual atoms. And then at the end of the reaction, we have our two products, where A is bonded to C and B is bonded to D. This is shown in both the written symbol equation and in the diagrams at the bottom of your screen. How do we know if there's been a chemical change though? Take 30 seconds to a minute, pause the video and think about any chemical reactions you know. How do we know it's happened? First of all, there could be a colour change. Here, a clear solution goes from purple to blue to green, and now it's changing slightly again. As you can see in this video, from two liquids being mixed together, we have gone through a wide variety of colours. So, can you think of any other reactions where there is a colour change? Any that you may have seen in school, at primary school, or indeed at home? Another way we can tell that a chemical reaction may have taken place. Oh, here's another colour change that we could look at. So here it goes from a really dark purple, similar to in the first video, and then it goes to this really dark green.
Potassium permanganate on the magnetic stirrer. Observe the changes.
Notice how we're spinning the liquids the whole time so that the reaction continued to happen.
Potassium manganate has green color. The oxidation
now goes to a funny brown mud chocolate colour, and that reaction continues. There could also be a temperature change associated with the chemical reaction. So if you play sport, you may have seen those instant cold packs where you have two compartments in a pack and you have to rub it together and snap it to have and then suddenly it goes really cold and you can put that on your knee or your ankle or wherever you've hurt. We have some reactions where things get very hot, so things like a combustion reaction, which is when we burn something. So this match is being burnt and there is a temperature change. We can also have those hand warmers that you may have had where there's a dark powder in, and as you rub them together those solids react and the packet gets really, really hot very quickly. So there could be a temperature change associated with your reaction. There may also be some effervescence or fizzing, and this often happens when a gas is produced as a product. So the classic example of this is when someone puts Mentos in a bottle of Coke. Another one is the reaction elephant's toothpaste, which I do recommend you go and have a look at on YouTube. It really is a great reaction to watch. We could also have something called a precipitate formed. Now a precipitate is where there is two liquids that when they react they form a solid, and that solid is not able to dissolve. Can you remember what a solid that does not dissolve in a liquid is called? We call these solids insoluble. So a precipitate is an insoluble solid formed from two liquids. So here we are adding two different colourless liquids, and as you can see, we're slowly getting a blue solid suspended in the solution. Here is a different reaction, and we're getting this orange colour solid, and no matter how much you stir these liquids, these will not dissolve. They stay suspended or floating in the liquid. As you can see, you can make some really beautiful patterns in the liquids of these precipitates by adding them very slowly, drop by drop. And depending on the liquids that you add, depends on the colour of your precipitate.
The solutions are made using water as the medium for dissolving ionic compounds such as salt, sodium chloride, or silver nitrate and potassium thiocyanate.
Okay, another thing that may happen when you have a chemical reaction is the magnetic properties may change. So something that was magnetic may no longer be magnetic, or vice versa. So in this video we're going to watch the burning of a match, and at the end of a match head is a chemical called iron oxide. Now iron oxide is not magnetic, but once it's reacted it forms pure iron, and iron is magnetic, and that's what we're going to see here. So they're picking up some of the iron oxide onto the end of the match. They're now burning it and putting it out. They're then crumbling off the end of that match so that you've got it as a powder, so it's easier for it to move. And you can see when they lift the magnet that there is some bits that actually follow the magnet around. And that is your pure iron. Let's just go and do a bit of a close-up for you so you can see it in more detail. Okay. Okay, so now could you do a little recap activity for me, please? Can you complete the activity on the right using the knowledge that you gained from the last two lessons? So you need to draw a line to say whether each of these molecules is an element or a compound. So pause the video and have a little go at this very short activity. Then you've got a few questions to answer, and I would like you to upload the answer to these on Teams, please. Pause the video and answer these questions in full sentences in your books, please. Finally, there's another little retrieval activity. So I would like you to create a glossary of the following words that were included in your first topic of the year. So you can either look back in your book to help you, or you can use BBC Bite Size. And I've added a link for you here that may help. That's it for today, Year 7. Thank you very much, and I look forward to seeing all of your work on Teams very soon.